Hello and welcome to Algebra 1, Lesson 38. In this video, we're going to learn about factoring by grouping. So before we kind of jump in and start talking about factoring by grouping, I just want to revisit what we did in the last lesson. So our last lesson, as you'll recall, was all about factoring out the GCF, or again, the greatest common factor. So if I had something like, let's say 5x to the fifth power minus 15x cubed, how would I go about factoring out the GCF? Well, essentially, the first thing I'd have to do is find the GCF. So between these two terms, I have a 5 here, and I have a 15 here. Now, 15 is divisible by 5, right? 15 divided by 5 is 3. So the number part for the GCF would be a 5. That's simple enough. Now, for the variable part, it's even simpler. In each case, I have an x, and I just go with the smallest exponent that appears in either term. So the smallest exponent is a 3, so this would be 5x cubed for the GCF. Now that's the easy part. Once we've gathered our GCF, what we're going to do, we're going to put equals, and we're going to place that GCF outside of a set of parentheses. Now, what's going to go inside the parentheses? We'll have two spaces for those two terms, and then our minus sign, don't forget about that. Now, how do I figure out what goes in each space? Well, I want you to think for a minute about what you're doing. We talked about this in the lesson. This is going to be multiplied by this, and it's going to give me this. So we have multiplication here. The opposite of multiplication is division. So if I want to figure out what this unknown is here, all I need to do is take the original term, which is 5x to the fifth power, and divide it by this 5x cubed, and I will get my missing term here. So 5 over 5 is 1, right? That would cancel. And then x to the fifth power over x cubed is x squared. So this would be x squared here. And you can see that works itself out because 5x cubed times x squared would get me back to the original 5x to the fifth power. We're going to do the same thing for this term right here, this 15x cubed. I'm going to, again, divide it by the GCF. So 15x cubed over 5x cubed. Because, again, this times this, okay, will give me back this. So, again, I can find that unknown by dividing this by this. Okay, so now what we're going to do, I'm going to cancel the 15 with the 5. This is going to be a 3. And then x cubed over x cubed is 1. So this will just be a 3 here. And again, check that with multiplication. 5x cubed times 3 gives me 15x cubed. So if you went back, okay, and you use your distributive property, 5x cubed times x squared will give you 5x to the fifth power. Then minus, you have a minus there. 5x cubed times 3 will give you 15x cubed. So you get back what you started with. And again, one more time for those of you who don't like to do the division, I know it's confusing for some of you. You could write this out if you wanted to. You could say, okay, this is 5 times, let's say we do it like this, x cubed times x squared minus, we could do 5 times 3 times x cubed. Now, if I'm going to pull out a 5x cubed, so let me kind of use a different color here. If I'm going to pull this out here, and I've got to circle it here and here, you just look at what would be left. So if I write a 5x cubed here, what would go in the space in each case is what's left. So you'd have an x squared there, so an x squared, and then you've got your minus, and then what's left over here? Well, just a 3. So just a 3 right there. So that's an alternative method for those of you who don't like to do the division. I know it confuses some of you, especially, in your Algebra 1. Once you get to Algebra 2, you've done this enough, so it'll kind of make more sense for you. But this is an alternative method if you just can't get the division down. Okay, so let's look at something else real quick. We're going to kind of keep this. We're going to go to a different screen here. And I want to show you something that's very similar to that, but just a little bit more complicated, just kind of one step up the ladder. So let's say I saw something like x squared times 2x minus 5, and then I had plus, let's say I had 3x times 2x minus 5. So at this point in your kind of algebra class, you've probably never seen or heard anybody talk about a common binomial factor. But that's what we have here. The first thing I want to point your attention to is that this is multiplication here. Stick something outside of parentheses, you're multiplying. So I have x squared that is multiplying this whole quantity, 2x minus 5. So these are factors. Same thing goes over here. So I have 3 is a factor times x, which is a factor times, again, the quantity, 2x minus 5. So these are all factors. Now, I have a common binomial factor. Binomial is just a polynomial with two terms, of 2x minus 5 in each case. What I can do is I can actually factor that out the same way that I factored the 5x cubed out in this example here. So let me kind of show that to you. Let me erase this real quick. And I know it's a little confusing at first. So the first thing I'm going to do is put brackets around this just to make it obvious what I'm going to do. So x squared times, again, 2x minus 5 plus 3x times 2x minus 5. Now, if I was to pull this out of the brackets, let me kind of scroll down, and I'm going to visually show that to you. So let's say I drag this down here, and I pull it out. So I'd have 2x minus 5 out in front of the brackets now. So let me put the brackets there. What's going to be left in each case? Well, I've pulled this out from here, so it's not there. You can kind of think about it as we did in the last example with the division. You could say if I had x squared times 2x minus 5, and this was over the quantity 2x minus 5, well, I have a common factor here of 2x minus 5, so that would cancel, and I'm just left with x squared. Again, you could just picture it as I'm pulling this out, so I'm just left with x squared. However it makes sense for you. Long story short, I'm just going to have x squared here, and then plus, this is pulled out from here, so I just have a 3x. So plus 3x. And instead of brackets, I could just use parentheses. Any grouping symbols will do. And what I have is, I have 2x minus 5 times I have x squared plus 3x. Now we're going to learn later on that we can further factor this, and we can pull another x out, right? Because that's common to each term here. But for right now, let's not even worry about that. Okay, let's just keep it as it is. So that is what factoring by grouping is going to entail. We're going to pull out a common binomial factor. And you're going to see that kind of moving forward. But before I go on, I want to show something to you. I want to prove to you that this is still equal to this. And a lot of you will doubt that. But I want you to notice, let me kind of erase this real fast. I want you to notice that this is nothing more than the way we used to multiply these guys together, right, before we learned FOIL. We would take this guy right here, and we'd multiply it by each term of the second polynomial. So that quantity 2x minus 5 would get multiplied by x squared, which it is here. Then plus, we'd have 3x multiplied by that polynomial again. So if I did FOIL on this, 2x times x squared is 2x cubed. The outer would be what? Plus 6x squared. The inner would be minus 5x squared. And then the last would be minus 15x. So if I combine like terms, I would end up with 2x cubed, and then plus x squared, and then minus 15x. And I'm going to show you that you're going to get the same thing up here. Let me kind of erase that real quick. X squared times 2x is 2x cubed. X squared times negative 5 is minus 5x squared. And plus 3x times 2x is 6x squared. And then 3x times negative 5 is minus 15x. So if I combine like terms here, again, I'm going to get plus x squared in the middle. So 2x cubed plus x squared minus 15x. Again, 2x cubed plus x squared minus 15x. All right, so let's scroll down now. We're going to talk about what factoring by grouping is and how you execute that process. All right, so when a polynomial has 4 terms, we can sometimes factor using a method known as factoring by grouping. And when we say grouping, we're just putting it into 2 different groups. So I'm going to show you that right now. So we're going to rearrange the terms into 2 groups. Again, 2 groups. And since there's 4 terms in the polynomial, we have 2 groups of 2 terms each. And we're going to do that so that each group has a common factor. And in some cases, the common factor might be 1 or -1. So then the next thing we want to do is factor out the GCF, or again, in some cases, it might be the negative of the GCF from each group. Then, if the result yields a common binomial, okay, just like we saw in that example we looked at a minute ago, we want to factor this out. If the result does not yield a common binomial factor, you want to try a different grouping. So you might need to rearrange your terms and set it up into another 2 groups of 2 and just try again. All right, so let's take a look at the first one. So I have 15x cubed minus 25x squared plus 9x minus 15. So the first thing I always do is I try to think about, if I set it up into 2 groups of 2, just as they are, could I pull something common out from each? So if I look at these 2 terms and I made them into a group, I see they have a 5 that's common and an x squared that's common. So I could pull that out. If I look at these 2, they both have a 3 in common. So let's go ahead and try that, setting this up into, again, 2 groups of 2, with this being 15x cubed minus 25x squared. Let's make that into a group. Then plus, we'll have a group of 9x minus 15. And again, I already told you the GCF for each. For this one, it's what? It's 5x squared. For this one, it's 3. So let's pull that out from each one. So if I pulled out a 5x squared from here, what would I have left inside? 15x cubed divided by 5x squared would be 3x. Then I have the minus. 25x squared over 5x squared is 5. And then plus, if I pulled a 3 out from here, 9x divided by 3 would be 3x. Then minus 15 divided by 3 would be 5. So we can see that immediately we have a common binomial factor. We have 3x minus 5, and we have 3x minus 5. So we're going to pull this out. Okay, we're going to pull this out. So again, imagine I have parentheses around the whole thing, and I pulled out the 3x minus 5. What would be left inside? Well, I'd have a 5x squared plus a 3, right? Because this was pulled out. I can just kind of draw an arrow down here. That's pulled out, put outside. That's what's left inside, the 5x squared plus the 3. So we have successfully factored this by grouping. So what we can do is use FOIL here, and we can prove that these 2 would multiply together to give us that original 4-term polynomial. So 3x times 5x squared is 15x cubed. Then 3x times 3 is plus 9x. Then negative 5 times 5x squared is minus 25x squared. Then negative 5 times 3 is negative 15. And if I reorder the terms, I get 15x cubed minus 25x squared plus 9x minus 15, which is exactly what we started with. Now let me erase this real quick, and I want to show you that this would also work with a different grouping. So let's say you decided to reorder the terms, and you said that you wanted to look at, I don't know, 15x cubed plus 9x. Let's say that's a group, because you can see that there's a 3x that's common, right? There's a 3x that's common. And then you have another group that's negative 25x squared and minus 15. And what's common here, I'm going to pull out a negative and then a 5, right? So negative 5 is common to both. So if we do that, what would we get? So let's put parentheses around each. Let's put parentheses around each. And again, I'm going to pull out a 3x from here. So 3x times, inside I would have a 5x squared plus a 3. And then from here, remember, I'm going to pull out a negative 5. So I'd have plus, and I'm going to have a negative 5 out in front. And then inside, I'd have what? I'd have 5x squared plus 3. Now, I didn't have the same binomial factor, but what's interesting is that if I look at this here and I pulled this out, what I'm going to end up with is the same thing in the end. I have what? I have 3x minus 5, which is what I ended up pulling out last time times 5x squared plus 3. So I end up with the same two binomials, right? But it's a little bit different how I got there. Now I want to show you one last thing. If you had chosen to do, let's say, 15x cubed minus 15, let's say that's one group, and then negative 25x squared plus 9x, let's say that's another group. This would not yield a common binomial factor. So what's common here would be what? It would be 15. So if I pull out a 15 here, I would have x cubed minus 1 inside the parentheses, right? 15x cubed divided by 15 would just be x cubed. And then negative 15 divided by 15 would be negative 1. Then kind of thinking about over here, I could pull out an x or a negative x, however you want to do that. Wouldn't matter either way. So let's pull out a negative x. So let's put minus x times, inside of here, we'd still have 25x. And then here we'd have a minus 9. So you can see that you don't have a common binomial factor here. You have x cubed minus 1, and you have 25x minus 9. Not a common binomial factor. So this is one of the scenarios where you might have set it up like that and said, okay, well, there's something common to each one that I can pull out. You pull it out, you don't have a common binomial factor, so you have to try a different grouping. All right, let's take a look at another one, and we'll kind of speed through these now. So we have 15n cubed minus 9n squared plus 10n minus 6. So I always like to look at the way they're set up. I start out with these two and these two. So I'll say, okay, what could I pull out of here? Well, I could pull out a 3n squared. What could I pull out of here? Well, I could pull out a 2. So mentally, you can kind of look at it and say, well, if I pulled out a 3n squared here, what would I have left in here? Well, I'd have a 5n, and I'd have a 3. If I pulled out a 2 here, I'd have a 5n, and I'd have a 3. So I already know that's going to work out, right? That's what you're going to do kind of moving forward. You're going to kind of do the groups here, right? You're not going to go through all the tedious process of writing everything out and doing. You're going to do it mentally and then figure out what group is going to work. So I'm going to pull out, again, a 3n squared from that first group, and that's going to give me a 5n minus a 3, and then plus, I'm going to pull out a 2, and that's going to give me a 5n minus a 3. So I have my common binomial factor here, which is 5n minus 3. Okay, 5n minus 3. And if I pull that guy out, what am I going to have? So I'd have 5n minus 3 times, what would be left? If I pulled out a 5n minus 3 here, I'd have 3n squared. If I pulled out a 5n minus 3 here, I'd have a 2. So plus 2. And so this is my factored form. I have the quantity 5n minus 3 times the quantity 3n squared plus 2. And in the interest of time, I'm not going to check it, but if you went back and used FOIL, you would get this 4-term polynomial back. All right, let's take a look at another one. So we have 35mn plus 5m, and then we have plus 28n plus 4. So again, let's check these first two and the last two. So if I pulled out a 5m, what would I have here? Well, this would be 7n, and this would be 1. If I pulled out what's common in both, which is 4, this would be 7n, and this would be 1. So that's exactly what we need. So let's go ahead and do that. So we'll put equals. Again, in this first one, I'm pulling out a 5m. And what's left inside, 35mn divided by 5m is 7n. Plus 5m over 5m is 1. Plus, when I'm pulling out of this group, I'm pulling out a 4. So 28n divided by 4 is 7n. And then plus 4 over 4 is 1. So you can see we have that common binomial factor of 7n plus 1. Okay, that quantity there. So if I pulled that out, I would have 7n plus 1 outside. And then I would have 5m, that's left here, 5m. Plus, from here, this is gone, so I just have a 4. So I'd have the quantity 7n plus 1 times the quantity 5m plus 4. And again, if you use FOIL to check this, you're going to end up with this exact same 4-term polynomial back. All right, now sometimes you're going to have a common factor for all terms present before we begin the process. It's best to pull this out before you start because if you don't, you're going to end up with additional factoring in the end. So if I look at these terms here, everything is divisible by 8. 320 divided by 8 is 40. 40 divided by 8 is 5. 128 divided by 8 is 16. And 16 divided by 8 is 2. So we can pull out this common factor of 8 before we even start. So in other words, this is what this would look like. I'd put an 8 out in front. I'd put some parentheses. And then I'd say, okay, well, I have 40xy. And then plus, I have 5y. And then minus, I have 16x. And then minus, I have 2. Now, once we've done that, we just factor the inside part, just like the 8 doesn't exist. Don't even worry about that. Just leave it outside the parentheses. We're going to worry about that at the very, very end. I'll show you what to do with it. So just work on this. So again, we could just go with the groupings that are present at first, see if they work out. So these two and these two. So 40xy and 5y, common factor of 5y, that would be 8x plus 1. And then 16x and 2, well, they're both negative, so I could pull out the negative part, and I could pull out a 2. So if I pulled out a negative 2 here, I would have 8x left. If I pulled out a negative 2 here, I'd have plus 1. So it looks like that would work out, right? We'd have that common binomial factor. And again, this is something you're going to want to do mentally. If you go through and write it all out, it's going to take you a little bit longer. So I'll rewrite the 8, and then I'm going to split this up. So 40xy plus 5y, the GCF there is 5y. So 40xy divided by 5y would be 8x. And then plus 5y over 5y is 1. Then we have this minus 16x minus 2. I'm going to pull out that negative part also, right? They're each negative. I'm going to pull that out because I noticed that here I have a positive. Okay, so I want that so I can have a common binomial factor. So that's a situation where we're pulling out the negative of the GCF. So I'm going to pull out negative 2. And let me just put plus negative 2 because that always looks a little better to me. So plus negative 2 times, inside of here, 16x over 2 would be 8x. And again, I've already taken care of the sign, so I'm just thinking about the numbers as if they were positive. And then 2 over 2 is 1, so plus 1. Okay, so let me kind of close the parentheses here. And again, you can see you have a common binomial factor. 8x plus 1, 8x plus 1. So that's what we're going to factor out. So I have the 8 out in front. That's going to stay there. And then times this common binomial factor, that's 8x plus 1. And then times, what's going to be left inside here? Well, what I'm going to have, if 8x plus 1 was gone, so if I just line that out, I'd have a 5y. Then plus, if 8x plus 1 was gone, I'd have a negative 2. So you can put plus negative 2 or you just put minus 2. Doesn't really matter. And close the parentheses there. And we have our answer. We have 8 times the quantity 8x plus 1 times the quantity 5y minus 2. Now this is factored completely. I'm going to show you what would happen if you didn't do this step when you begun. You would have had something that had additional factoring that needed to be done. So if I look at these two groups here, what can I pull out? Well, I can pull out a 40y. So I'd pull out a 40y, and I would have what? I would have 8x plus 1. Then over here, I could pull out negative 16. And inside, I'd have, again, 8x plus 1. So if I factored the common binomial factor of 8x plus 1 out, I'd have 8x plus 1 times what's left inside would be 40y. This would go away. And then you just have the negative 16, right? Because this would be gone. So minus 16. And if you look at the 8x plus 1, that's fine. There's nothing else I can take out of there. But if I look at this right here, if I look at 40y minus 16, there's something I can pull out of there, right? 8 is common to both. So if I report my answer like this on my test, my teacher is going to go over here and she's going to put wrong. Because I didn't factor completely. There was something else I could have pulled out. Okay, you got to keep that in mind when you're doing a test or homework. You might have factored, but you didn't factor completely, so the answer is wrong. If I pull out an 8 from here, 40 divided by 8 is 5. So this should be 5y, so this 8's going to go out here. And if I pull out an 8 from here, this would be 2. So this is how we got our original answer, but again, I pulled out the 8 to begin with, so I didn't have to go through that additional step in the end. So if you don't want to pull it out and you want to do additional factoring in the end, that's fine, but you have to look for it. Right? You have to always be looking for additional factoring that needs to be done, because that's the quickest way to get either a wrong answer or at minimum points off on your test or homework by not factoring completely. Right? So the answer here is 8 times the quantity, 8x plus 1 times the quantity, 5y minus 2. All right, let's take a look at another one. We have 60a cubed z minus 15a squared yc plus 45a cubed c minus 20a squared yz. So again, if I look here carefully, I notice that 5 is common to everything before I even start, and also a squared is common to everything before I start. So before I do anything, I can pull that out. So I can pull out a 5a squared and rewrite this whole thing here. 60 divided by 5 is 12. A cubed over a squared is a. So az minus 15 divided by 5 is 3. A squared over a squared is 1, so this should be yc. Plus 45 divided by 5 is 9. A cubed over a squared is a. And then times c. And then minus 20 over 5 is 4. A squared over a squared is 1. And then yz. Okay, so now I just go through and factor by grouping just as I normally would. So again, I'm going to look at what's already in order. So these two as a group and these two as a group. Would that work out? I have 12 and I have 3. So the greatest common factor there would be 3. I have az and I have yc. So nothing I can pull out for the variables. So if I did that, I would end up with what? I would end up with a 4az. And if I pulled out a 3 there, it would be minus yc. And so here, I would end up with what? 9 and 4, nothing I can really do there other than 1. AC and YZ, nothing I can really do there. So 1 is the only thing I could pull out. So you'd have 9AC minus 4YZ. So we would not yield a common binomial factor here. So we would have to reorder our terms to get a common binomial factor. So let's go ahead and try a different grouping. So I noticed that this has a Z and this has a Z. This has a 4. This has a 12. 12 is 4 times 3. So let's try writing 5a squared times the quantity, 12az. Then I'm going to put minus 4yz. So this could be a group. And then minus 3yc plus 9ac. So now let's look at the way it's set up here. So, and this one's a little complex, so I'm going to actually have to write it out. So I'm going to put 5a squared times, what's common here? I have a 4 and a z, right? So I could pull out a negative 4z also, but let's see if we need to do that. Let's just start out with positive 4z. So what's going to be left inside the parentheses? 12 divided by 4 is 3. Z over z is 1, so just 3a. Then minus 4 over 4 is 1. Z over z is 1, so just y. Now I have this negative out in front. With these two, it's a negative 3yc, and it's a positive 9ac. So I can start by just factoring out a negative 3c. So I'm going to put negative 3c out in front, and I like to put plus negative. That's just me. So I'm going to put plus negative 3c. And then inside, if I pulled out a negative 3c, I would just have a y. And then if I pulled out a negative 3c, all that's going to happen here is the sign's going to change. So this would be negative, and then you'd have a 3, right? 9 over 3 is 3. And then the c would cancel, so you just have an a. Now, I don't have a common binomial factor yet, but we're close, right? We have a y and a y, and we have a 3a and a 3a. It's just the signs that are the problem. So if I was to factor out a negative here, then this sign would change and this sign would change. So positive y and positive y negative 3a, and negative 3a. So that would work out. I just changed the order. Remember, you can change the order. It won't matter. And let me just change the order here to y minus 3a. And I know this is a little complex when you first see it, but this is some of the problems you're going to get thrown at you, right? Where you have to, rework things and change the signs. And if you get something that's close, like we just got, it's usually just a sign that you're off by. So try a different sign on each one. All right, so now we can go ahead and pull out our common binomial factor, which is y minus 3a. So I'll have my 5a squared out in front. Not going to touch that. Inside, I'm pulling out the y minus 3a. So y minus 3a. And then what's left? If I pulled this out from here, if I canceled it basically, I would have a negative 4z. And then I would have a minus 3c. This would be canceled, right, if this was canceled. So I have my answer. 5a squared times the quantity y minus 3a times the quantity negative 4z minus 3c. And again, if you want to use FOIL here for these two, and then multiply that result by 5a squared, you're going to see that you get this original 4-term polynomial, 60a cubed z minus 15a squared yc plus 45a cubed c minus 20a squared yz. And then one additional thing you might want to do, and I'm not sure if your teacher requires you to do this or not, but a lot of times they don't like any of the leading terms in here to be negative. So you could further factor this and factor out a negative 1. So you could pull this guy out and this guy out and just change the sign. So I would just put a negative 1 all the way out in front. So I just put a negative sign out here. And so this would turn into a positive, and then this would turn into a positive. And so you could also write the answer as negative 5a squared times the quantity y minus 3a times the quantity 4z plus 3c. And again, if you go through and you multiply negative 5a squared times the quantity y minus 3a, and then you could do FOIL with that result times this, you're going to get your original 4-term polynomial back, the 60a cubed z minus 15a squared yc plus 45a cubed c minus 20a squared yz.